y is equal to sine of x. So pi over 2, 3 pi, and this one is 3 pi over 2. Okay, what are the maximum and minimum values? 1 minus 1. Okay, this is x-axis. Now I will plot the inverse. I mean, it's the same graph. It's the same graph I am plotting, but this time I put y here, x here. Correct? Agreed? That is what is going to give us the inverse, right, for a given value of y. Now here the problem is, if I, let's say, take this function, okay, then I choose some value of y. Let's say I choose this value of y, and ask what's the corresponding value of x. That is what is the inverse function gives. This value of y corresponds to this value of x. This one corresponds to this value of x, corresponds to that value of x. Infinity of them. Right? So if I have a function which I want to define as an inverse function, for a given value of its argument, it takes infinite values. I cannot work with that. Okay? So let's first plot this thing. So yeah. Okay. So it will go like this, okay? You can see that, okay? The way we have been talking about inverse function, you can say if it is doing this, it will do this here. Now, if I want the function to be single valued, that it, for a given value of its argument y, there should be only one value of x. Then what I should do is, here itself I should restrict the values of x. So instead of allowing all values of x, I will do the following. I will just restrict to minus pi over 2 to pi over 2. When I am between minus pi over 2 to pi over 2, the function is just this segment, right? It's a monotonic function. It's increasing. It doesn't turn around and mess it up. So if I take only this part, it's monotonic. And you see, if you choose a value of y, there is a correspondingly unique value of x. You never get two value or three values. Okay? So I am going to restrict, look here, I am going to restrict x between minus pi over 2 to pi over 2. Okay? See, I could have taken the endpoints. I could have taken pi over 2 and minus pi over 2 also. But I am leaving them out. I am leaving them out because, see, it will correspond to this. This part, inverse, corresponds to this. Here the derivative is becoming infinite. Exactly at that value of pi over 2. Okay, so when y is equal to pi over 2 and when and y is equal to minus pi over 2, you see the slope is vertical, it's infinite. So if I leave that point out, I have finite values of the derivatives.
When they are 1, 1 and minus 1.
Sorry, thank you. 1 and minus 1, here it's pi over 2 and minus pi over 2. Correct. Okay? So I'm just leaving exact that point out where the slope becomes infinite. Just before that, it's large, but it's finite. Okay? There's nothing like just before that. There's nothing like just before that. Okay? But if you leave that point out, it's fine. So I will take that part. So, what's the inverse function? Sine inverse y is equal to x. Right? That's what is x? This. What is the meaning of sine inverse y? Exactly that. That's the definition of it. Okay? Y is going to be restricted between minus 1 and 1. Okay? But unless you make this choice, this is not enough, because even if it was doing like this, right? it is always between -1 and 1. So when you make such a choice here, when you restrict the values of x, you are choosing what is called a branch. Okay. Now you say, okay, you are suppose very rebellious person, okay, a teenager who doesn't like conforming to society. You say, no, I will not take this. I will take this. Because here this is again monotonic within that much. Yes, you can take. So for a given value of y, you will have a unique value of x. In that will be a different branch of the inverse function. Okay? So those are all different branches. So let's work with this branch where the x values are restricted to this. It is called principal branch. Okay? So this branch is called principal branch when the values of x are between -π/2 to π/2. Okay?
Only for this function, right? No.
Only for this function, these values give a principal branch. Depending on the function, you will have different values of x for which you will
How do
separate.
we choose the principal branch?
Well, for now, just a name. All branches are same. Okay? So there is no, it's not like intrinsically this one is better than that one. But principal one for which, in this case at least, it's symmetric about x equal to 0. Convention, just a name. See, mathematics cannot tell you which one is better. There is nothing better in whether this branch is better or that branch is better. This one is more important, that one is more important. It is just that the values lies between this range. Okay, physics can. Physics will tell you which branch to take. But anyway, we are doing mathematics right now. So, agreed? That's the principal. This part if we take, then that's the principal branch. If you take this part, correspondingly that part will be the principal branch. That part will be a different branch. Okay, that is all about inverse function. Now we should talk about derivative. Right? That is what our goal was. I have a single valued function. Derivative exists at all the points. The point at which it goes infinity I have removed. I am good to go now. Okay. So till now we were verifying, but now we can use dy over dx times dx over dy, where dx over dy is the derivative with respect to y of the inverse function, right? What is x? X is sine inverse of y. So this is d over dy of sine inverse of y, correct? And that should be 1. Maybe I'll write it down using this. It's d over dx, y is sine of x, times d over dy, x is sine inverse of y. And that should be, according to our theorem, it should be 1. Okay? Remember, when we write sine inverse of y, this is not this. This would mean 1 over sine y. Okay? So the notation for inverse function, for trigonometric functions is like this. These two are distinct things. This would mean 1 over sine of y. Understand? See, for example, if you write x power minus 1, that's 1 over x. So when you write this, you read as sine y raised to the power minus 1. You don't say this is sine y inverse. No. This is sine. This you don't read as sine y raised to the power minus 1. No. That's sine inverse y. Okay. Is this clear? These two are different things. Okay. So we have this theorem. And I can use it to find sine inverse of y. I will just erase this. So what is sine derivative of sine inverse of y? d over dy of sine inverse of y is equal to 1 over, what's the, so I am taking this to the other side, that's the derivative of sine x. What's the derivative of sine x? Cos x. Agreed? Right? This thing is here, that's 1 over this, okay? Now let's use the identity sine square x plus cos square x is equal to 1. So you have the identity okay, that's identically 1, meaning this equation is true for all values of x, that's why it's called an identity. So what is cos of x? 1 minus sine square. Cos square of x is 1 minus sine square of x. So cos of x is equal to is that correct? No, it's not correct. Plus minus. I am taking a square root now. There are two solutions. Fine. But then which one should I take? Both? Is a derivative of a what happened? Is derivative of a single valued function going to give you two answers? No. You have a single valued function. You are just asking what's the slope at this point, what's the slope at that point. Do you have two slopes at one point? No. So you don't expect two answers. Right? But this is saying two possibilities. You understand? Geometrically you have a picture, right? That this makes no sense. So we have to select one of them. How do I select? I have cos of x. Okay? I have already restricted the values of x. So I ask, if x lies between minus pi over 2 to pi over 2, is cos positive or negative in that? Okay? You understand? Since x is restricted. So let's see. From minus pi over 2 to pi over 2. So that's 0, right? So 0 pi over 2, 0 minus pi over 2. No, sorry. This is pi over 2 from here. That's pi over 2 from here. That's minus pi over 2. So you are here in this region. When you are in this region, the cos is base over hypotenuse. Okay? So base is always positive. Whether you take this or you take that, the base here or here is always positive. So cos is always positive in this region. Okay, so here cos is positive. If cos is positive, then I should leave out the negative because that's not a solution. It's a solution of this one, but it is not consistent with this constraint. So I should choose only positive one. Agreed? Okay. What is 1 over 1 minus sine square of x is 1 minus sine of x was what? Sine of x is y.
1 minus y square.
So you get is that fine? So you can also find it in a different way, which you might have already seen, but I wanted to tell you this way because it's going to be extremely useful. And also it's such an important relation. You now know the relation between the derivative of function and the derivative of its inverse, right? So that's useful. So d over dy of sine inverse of y is 1 over 1 minus y square, okay, where we are looking at principal branch. If you don't say this, then your answer is not correct. Okay? I will show you what's the derivative of sine inverse of x for a different branch, and we will see that you will get a different answer. So it's very important to specify the branch. So now let's change the variables. Instead of calling y, let's call it x. Okay? So I will just change the names. So d over dy, d over dx of sine inverse of x is equal to 1 over 1 minus x square, the square root, for the principal branch. Okay, meaning sine of x, when I'm looking at sine of x is restricted between this one. Okay, or equivalently, when I'm looking at inverse function values are restricted between this. Okay? So I should say here, agreed? If you see here, this is sine inverse of x, right? This is the graph of sine inverse of x. Then I have to read x here and sine inverse x here. I have to change the labels if I'm going to interpret my last equation which I wrote there this way, then this is sine inverse f x, that is x. Now x is restricted between -1 and 1, and sine inverse x is restricted between -pi over 2 to pi over 2. Okay, that is what I have written here. Sine inverse of x is restricted between -pi over 2 to pi over 2. Anything wrong? All fine? Okay. So let's box it. What do you suspect?
Shouldn't the principal branch be -1 to 1? Because this is the inverse function, right? This is sine. This is.
See, -1 to 1 is always there. The value of sine is always from -1 to 1.
This is, yes, that.
Let's go here and then you ask. Wait. Yeah, tell me now. Do you agree this is correct? As a function of x, now I've changed the labels, okay? As a function of x, this is the graph of sine inverse. This is not a graph of sine x.
Yes.
This is correct?
And in this, we are looking at the interval -1 to 1, not pi over 2 to -pi over 2.
Yeah. I have not written the values of x should be between -pi over 2 to pi over 2. I have written the values of sine inverse x should be between. You are right. I have not written this. I have written this. Okay, let me tell. Suppose I don't put that restriction. Let me show you here. This is sine inverse x. I have not written x here. Okay? Now let's go.
Oh, okay. You did not write x there.
If I had not restricted, then this will go further like that.
Yes. I understand.
So for a given value of x, you will have infinite values of sine inverse x.
Instead of that, instead of writing minus sine sine inverse of x is between minus pi over 2 and pi over 2. You can also write. Can you also write x is between -1 and 1?
Yes, I can. No, that's a problem. No, I cannot. So let's say I just take this graph and write the corresponding inverse. Don't worry, without worrying about the multi-valued thing. That for a given value of y, I get many of those. So then it will be like this. You see, this is still between -1 and 1.
Oh.
It's not like it's going out. So when you are restricting, you are not restricting something here.
Yes.
You are restricting there.
I don't see that.
Is that fine?
Yes, right.
Okay. So, clear? Yeah, Bhagwan.
If the purpose is not served,
Huh?
if you just write x is equal to minus 1 to 1,
It is only from -1 to 1. It's not anyway not outside. Is that fine? So when I write this, remember when I write do dx sine inverse x is equal to 1 over square root of this is, that's not a complete statement unless you specify the branch. Okay? Because it's very easy to forget this qualification afterwards. I'm going to give you an example where I take again the derivative of sine inverse of x but over a different branch. And then you will see you get a different answer and you will not forget. Is that okay? Shall we go ahead?
Yes.
Y equal to sine of x, so that x is equal to sine inverse of y. This time I am going to restrict x. So see here, the function is monotonic, right? For a given value of y, you have a given value of x. This time I am going to take this one, this region. What's the value of x here? Pi over 2. What's the value of x here? Oh, something came out which I had never seen before. Anyway, 3 pi over 2, right? So if I take pi over 2 to 3 pi over 2, I have this branch. Okay? So I will find out sine inverse of y, derivative of that, over this branch. And what's the entire interval length? It's pi. Pi over 2 to 3 pi over 2 is pi. So we'll go to that branch. Okay, so our branch is x lies between pi over 2 to 3 pi over 2. Okay, that's interval length is pi. So if we repeat the steps, I will again arrive at sine inverse of y, derivative of that will be 1 over cos x. Okay, which is again 1 over plus minus square root of 1 minus sine square of x. That's what we had earlier. Now let's ask, again same thing. It's not like you are looking at a inverse function which is looking like this, and derivative meaning slope should be one fixed slope. It's not like two different slopes at one point, right? So I should select between these two. So when your angle x, so not this angle now, that's x, right? You understand, right? This is the angle x. It's not this x-axis. Okay. So cos of x, where x lies between pi over 2 to 3 pi over 2. Okay.
second or fourth.
So pi over 2, that is pi over 2, and this is 3 pi over 2. So from here to here, when your x lies, these are your x, this is your x. Agreed? Or this is your x. These are the possible values, all possible values. Cos in this is base upon hypotenuse. Hypotenuse is always positive, so base is going to be always negative, right? That's the negative direction. So base is negative, so cos is always negative in this region. So cos is negative in this region, so cos of x is less than 0 for our choice of, for this branch, which means I should not select the positive one, right? Because this is a positive quantity. So I should select a negative one. But then this is 1 over minus square root of 1 minus sine of x is y. Sine of x is y, so 1 minus y square. You see, I got a different answer. So let's box this one also. So d over dy of sine inverse of y is equal to this when sine inverse of y lies between pi over 2 to 3 pi over 2 when you are looking at this branch. And of course you can change the variable name y from y to x or z or whatever you like. So d over dx sine inverse of x is 1 over minus square root of 1 minus x square, where sine inverse of x lies between pi over 2 to 3 pi over 2. Is this clear? Okay, final example for today and the easiest one, and then we will stop. Any questions? Should remember this. Contrast this with the derivative of cos inverse y. Do you know what the derivative of cos inverse y is? Okay, find out. Derive it. Now deriving should be easy. And then what you should do is make a table of derivatives of sine inverse y, cos inverse y, tan inverse, cot inverse, secant inverse, cosecant inverse. And you should have a table, derive it, have fun. Yeah, that's a lot of fun. And then have it in your memory, okay? So you should know that what things you should keep in memory and what kind of derivations you should have in your memory. So homework is find d over dx of sine inverse of x, that I have done already. Is this problem well defined? No. I have not specified the branch. Okay, repeat the exercise for the principal branch. Then secant inverse and cosecant. Okay, next time when we meet, I will ask you whether you have done this. And do it for principal branch or maybe one branch which is different from the principal branch. Okay? Put these values, you should have the table next time. And always write the corresponding thing for all of these. Without that, it is not a good thing to do. Okay, final example. Let's look at the exponential function. Y is equal to e to the x. Then x is equal to
log base y
what?
base e log of y base e to base
Very
e.
good. So I will omit the e. Okay? It's fine. ठीक है? लिखने की जरूरत नहीं है कि e है वहाँ पर.
Natural log ln.
Yeah, it's the same, ln y. Okay? That's the thing. Now, do I have to worry about multivaluedness?
No.
No. What? Oh. No. Because for a given value of y, there is only one value of x. There is no for every point. So I don't have to worry about multivaluedness. Okay, I don't have to do anything, cut off this and that. Okay, good. X is equal to log y. Now, let's say d over dx of y times dx over dy. Not let's say, that's the theorem. But what is y? Y is e to the x. So using this theorem, that's theorem. Beautiful, lovely theorem. This is d over dx, e to the x, times d over dy. What is x? X is log y. That product should be equal to 1. So d over dy of log of y is equal to 1 over d over dx e to the x. Let's first find out what is d over dx in derivative of e to the x. What is that? What's, but what is e to the x? So that this result, this thing is e to the x.
Y.
So y times d over dy. Agreed? So what's the derivative of log of y? How? I've just divided both sides by y.
Oh.
Yeah. While differentiating, we forget about dividing. Is that okay? So if you replace, if you don't want to use the variable name as y and as x, you can write derivative of log of x is 1 over x. Now remember, when we were looking at the derivatives of polynomials, x cube derivative is x square, proportional to x square. X square proportional to x. X proportional to 1. 1 over x derivative proportional to 1 over x square. Proportional, it is minus 1 over x square. Okay, 1 over x was missing. That 1 over x is sitting here. Okay, so remember this. This result also you should have in mind.
So this is basically proof that derivative of log of x is 1 over x.
Yeah, that's what I proved. That's the proof of it. Homework, prove this in a different way using chain rule. The same result you can arrive using chain rule. Okay. The same result you can arrive at by using chain rule. Okay, here one thing. I'll give you something to think about. Okay? Whatever we have learned so far, with that, can you or can you not do the following? If I give you y equal to x power sine of x raised to the sine of x, can you find what is dy over dx? With all that we have learned so far? Yes? Then do it. No, we have never done that. How? No. No.
Chain rule.
Chain rule?
Yes.
It was function of function.
Yes.
Okay. Chain rule, I mean, of course, in some way, yes.
Chain rule.
Try doing it, okay? Of course, it's going, we are going to use chain rule, yes, that's correct, but try doing it, okay?